Only 18 minutes late, nothing too serious. Okay, luckily I didn't have a lot planned today. I think somewhere in the back of my mind I kind of knew something was going to go slightly wrong, not terribly. Okay, so what we want to finish today, we want to finish the section on bivariate data, specifically looking at the more complex questions. So you'll hear on the videos I spoke about the Luzandi method, the Michelle method, and the Josh method. So today we're doing the Josh method. This is pretty much all the level 3 and level 4 questions that you potentially ask on this section, which you'll see very shortly is really, really not that difficult. It's actually not complicated at all. Okay, so pretty much what we need to talk about, we need to talk about the influence Outliers has on this bivariate data. So, outliers do not follow the trend of the data. That's very important. So if they ever ask you, identify an outlier. So they say, identify an outlier, and you literally, because it's a full-in paper, you will have to either circle it and draw an arrow saying here, pointing at it, or you might have to just take a highlighter and highlight it. Okay. Sometimes what they do is they ask you, write the letter A next to it, write the letter B next to it. Just be very, very cognizant of how they want you to identify that outlier. So as you can see, in the first one, let's quickly check if you understood what we did on Friday. What kind of trend or correlation do you see in that first scatter plot? Strong, positive, linear. Got it. Strong, positive, linear. Absolutely. Okay. Can you guys still see your notes, by the way?
Yep.
Okay. Just going to get the light on at the back. Okay. So, but if you look at that one item over here, right over there, that is very clearly an outlier. Try and zoom in on the words. Well, I need to make sure it's over here, it's showing over there. Do you need, yeah, sure, zoom.
Oh, let's get to it. It goes right at the back. I can't see anything in terms of words.
Okay, no, that's fine. I can take it closer, like that. And I can move it slightly up, like
Yeah, I think rather do smaller sections on that side.
No, that's absolutely fine. Let me just move this to the side. There we go. Can you see that? Awesome. Yes, speak up. Okay. So you can clearly see this is an outlier right there at the top. It does not follow the trend of the data. And that is the exact word you're going to be using when they ask you, identify an outlier and give a reason why it's an outlier. So the reason is it doesn't follow the trend of the data. Then if you look at the second graph over here, you have that negative correlation going on, and then obviously over here at the bottom, you have an outlier. In that outlier specifically, okay, cool. That outlier specifically then also doesn't follow the trend of the data. So that's how you identify outliers, and that's also the reason you give for saying it's an outlier. It doesn't follow the trend of the data. Okay. Then, removing an outlier. And this is something they love asking. You'll see in the worksheet we're going to be doing now. There's lots of questions saying, if I remove the outlier, what will happen? So what will happen if I remove an outlier? Okay, this is interesting. Okay, here we go again. Number one, the correlation coefficient will change. Now this depends obviously on whether the correlation coefficient is positive or negative, because this is the tricky part. If the correlation coefficient, like in this first diagram over here, wow. Okay. In this first diagram over here is a positive one. And I remove that outlier. Then obviously, the correlation coefficient will increase. Why will it increase? Simply put, you remove the outlier, so the remaining points are closer to the trend, meaning the correlation is stronger. But because it's a positive correlation, stronger means the correlation increases. It gets closer to positive 1. Do you understand? Okay, but over here, if I look at this one, if I remove that outlier, again, stronger correlation. Why? Because the remaining points are all closer to the least squares regression line. But here, because it's a negative correlation, the correlation doesn't increase, it decreases because it has to go closer to negative 1. Do you understand the trick? So the correlation is positive, okay, so positive correlation, and we remove the outlier, then the correlation is stronger, but because it's a positive correlation, it's got to go closer to 1, so it's got to increase. If the correlation is negative, so you've got that negative correlation, and I remove the outlier, the correlation is stronger, but now be careful, it's got to go closer to negative 1, so the correlation has to decrease. Careful with those words. Because you might just go, and you might, with a negative correlation, say to me, oh yeah, the correlation will increase, and I will have to mark it wrong. It won't increase. It needs to go closer to negative 1. It will decrease on a negative correlation. It will increase on a positive correlation. Okay. Then, next thing that will change is the gradient of the least squares regression line will also change. Now that one, you can't just go and give any answer. With that one, you've got to look at what the graph looks like and what the least square regression line looks like. So if I had to go and draw a least square regression line for that first one over here, right there, then my least square regression line should have been, and let's just grab a ruler so you can see it a little bit better. Then my least squares regression line should have been over there. But because of the outlier pulls it slightly to that side. Do you understand? The outlier pulls it away from the other points. But if I remove that outlier, the least squares regression line, so if I remove this outlier, the least squares regression line returns back to the other points. So if I remove that outlier, that least squares regression line will become less steep. Do you understand? The outlier makes it more steep. The outlier pulls it over here. And if I remove the outlier, if I take that away, it becomes less steep. So that means my gradient will decrease because it's a positive gradient. So if I remove the outlier, the gradient will decrease. But with this data, right there, my least squares regression line should have been over there, but this point pulls it down like this. So if I remove that outlier, my line goes back up to there, which means it also becomes less steep. But that's negative, do you understand? So that's negative, it actually does what? Increases. Do you understand? Because of the negative, it increases. Yes, question there. Yeah, absolutely. So with a negative line, like over there, if I didn't have the outlier to begin with, we could potentially say that's a gradient of -1/2, because it's not a very steep gradient. So it's not like a -2 gradient or a -3 gradient, it's like a -1/2 gradient. You agree? But this outlier pulls it down in the direction of the outlier. So suddenly, that could be like a -1 gradient, because it becomes a little bit steeper. You understand? But I then go from a -1, removing this, to a -1/2. And if I go from -1 to -1/2, the gradient actually increases because it's negative. So pretty much what you have to watch out for with a correlation coefficient and with your gradient is when you want to go and say, oh, the gradient decreases, with a negative, you actually have to say the opposite. And you almost, if you want to check, you want to write some values down. Like the one I just showed you, where I said, this makes sense that the gradient is about -1/2. Okay? Then the outlier pulls it steeper, so that's about -1. But removing the outlier takes it back to about -1/2. And to go from -1 to -0.5 is an increase, not a decrease. You see, that's the only trick. So be very, very happy if you get to your final exam end of the year and you have a correlation that is positive, because a positive correlation is easy. Whatever your instincts tell you, that's right. Got it. The negative correlation is the problem, because that's always going to be the wrong way around. Okay, Josh.
Ma'am, what happens if the outlier, for example, is positive?
Yes.
Line is below?
What if the outlier was lying here at the bottom? So if you have an outlier here at the bottom, then that one could have a gradient say of about 1. The outlier will pull it down to about 1/2. So there, if I remove the outlier, the gradient will increase. It will go back. Got it? Okay, so that's pretty much what you need. Let's look at the worksheet, because the whole plan is that you guys should now go and do as many of these examples as possible. Okay, so there we go. Worksheet on bivariate data. So you can open that. I photocopied that for you guys. Man, I don't know why they switched off the lights. Really don't. Can you actually see what's going on? Kinda. I know. So anybody that knows how to switch off one of the lights, just somewhere so you guys can actually see what's going on. Okay. But can you at least see what you're writing on your notes? Okay, I'm just checking. Just checking. Okay, if you need to actually use a cell phone camera, use your cell phone, not your camera, your cell phone torch. Use your cell phone torch. Oh my goodness gracious, this is fun, people. Yes, that was my sarcastic voice, Michelle. Okay, so now in this one it says, in the diagram below, a scatter plot is drawn. The line of best fit for the entire data set is drawn. Now, remember I warned you guys about that word line of best fit. Because I said sometimes they use the word line of best fit, but actually they're talking about the least squares regression line. Got it? Technically speaking, the line of best fit and the least squares regression line is supposed to be the same line. Technically speaking, it is. But technically speaking, they can't ask you to find the equation of a line of best fit using your calculator. Because using your calculator, you're actually finding the regression line. Got it? But please, don't get too stuck on those words. Use them kind of interchangeably. Line of best fit, regression line, just use them interchangeably. Okay, so now, state whether the following statements are true or false, giving reasons. The point marked A is an outlier. True or false? True. And remember, I just told you what's your reason for saying that? It doesn't follow the trend of the data. If you forget the word trend, you can also go and say it's very far away from the rest of the data. That's pretty much describing what trend is. Trend means the data goes in a certain direction, so they're all very close together. So the moment you go and you have a point that isn't close together with the other data, it's not following the trend of the data, therefore it's an outlier. Okay, next. Okay, so let's write true. You know what, I'll do that later when I put the memo together. Okay, otherwise this is going to take forever. Next, removing the point marked A would result in a higher value for the correlation coefficient. True or false? True is correct. Who wanted to say true? Yes. Let me talk to you about this. Why? If I remove point A, then what's happening is all the other points is closer together, so the correlation gets stronger. And because that's a positive correlation, what needs to happen with the positive correlation if the correlation gets stronger? Needs to go closer to +1. So it's got to increase. It's only with a negative correlation, when you remove the outliers, that it actually decreases, because it's got to go closer to -1. Do you understand? So, true, removing the point marked A will result in a higher value for the correlation coefficient. Reason, number 1, correlation is stronger. Therefore, it's got to go closer to positive 1. So that's, therefore, it's got to increase. That's pretty much it. Right, next. Removing the point marked A would result in a smaller value for the slope of the least squares regression line. Listen again. Removing the point marked A would result in a smaller value. So let's quickly look at this. Currently, it's not really with those points. Do you understand? That's what it should have looked like if I didn't have that outlier there at the top. So if I didn't have the outlier there at the top, this is what it should have looked like. Because of the outlier, the line has been pulled up to there. Got it? So if I remove point A, the line will go back to about there. Is that going to be a bigger slope or a smaller slope? Smaller slope, because of the positive. So because it's positive, the slope is going to decrease. It's going to be less. So, true or false? True. True. And your reason is going to be removing the outlier at the top will make the line go closer to the other points, which will reduce the slope. Or reduce the slope, which will make the slope less.
No,
You can even use the word less steep. The line will become less steep. Yes. Yeah, you can say gradient as well. Because the slope is a gradient. Gradient slope is the same thing. So if you use the word gradient instead of slope, that's fine. But the point is, removing the outlier will mean the line will go closer to the other points, which means it will be less steep, so a smaller slope or a smaller gradient. That's pretty much it. I hate these type of questions because you always wonder, am I writing too much or am I writing too little? Yeah, not a fan of it. Okay, let's look at the next one. So, in the next one it says, refer to the statements below and answer the questions that follow. A line of best fit has an equation of y is equal to 57 minus 3x. And please remember, I told you guys about this on Friday. Whenever we do a least squares regression line, we never write it y is equal to mx plus c. It's always written y is equal to a plus bx. So it's always written like that. Yes, I completely agree. B is going to be the gradient of the slope, and A is going to be the y-intercept. But it's just convention in statistics that we don't write it y is equal to mx plus c. We write it y is equal to a plus bx. Okay, so they've given me that. Then they say there's one outlier that has been identified as the 0.94. So the 0.94 is an outlier. The correlation coefficient is very strong. Okay, correlation coefficient is very strong. If the outlier was removed, would the correlation coefficient be stronger? Yes or no?
Yes.
Yes. Removing the outlier always makes the correlation coefficient stronger. Now, luckily they use the word stronger. They didn't use the word increase or decrease. They just used stronger. Okay. And when you want to explain your answer, you'll just say that the other points, removing the outlier means the other points are now closer, okay, closer together. The remaining points are closer together. So that's got to make the correlation coefficient stronger. Now just quick question. If they hadn't asked the word, would the correlation coefficient be stronger? If they asked the word, would the correlation coefficient increase or decrease, what would you say here? Decrease. How do you know it's got a negative correlation? The B value is negative. There's a negative gradient. So the line that's given there, y is equal to 57 minus 3x, has got a gradient of minus 3. And I did tell you guys this on Friday. The gradient, the B value, and the correlation coefficient, their signs must always be the same. So because this line has got a negative gradient, it's got a negative correlation. So if they did use the word, is the correlation coefficient going to increase or decrease, you would have had to say it's going to decrease because it needs to go closer to -1. Everybody understands? Okay. Next. There's the question. Is the correlation coefficient closer to 1 or negative 1? You just see. Closer to negative 1. Why? Because my B value is negative, which means it's a negative correlation. So that means it's got to go closer to negative 1 to be a stronger correlation. Because it's got a negative trend or a negative slope. Then, if you were to make a prediction using the line of best fit, would it be perfectly accurate? Yes or no? If we were to make a prediction using the line of best fit, would it be perfectly accurate? Yes or no? Never perfectly accurate. Never perfectly accurate. They said that the correlation is very strong. Now, removing that outlier means it could get stronger. Clearly, it could get stronger. But we have no guarantee that it's going to be a perfect correlation unless we can see the correlation coefficient. So you can write something like, for instance, no, because we don't actually know how close to negative 1 the correlation is, number one. Or number two, you could have said no, especially if it's going to be extrapolation. They have to give you credit for that. Because the moment you extrapolate, if you sub in an x value that doesn't lie in the domain, then you know for a fact it's inaccurate. So you can use that also as a reason. But you guys understand, you've got to use certain words. You've got to use certain words like trend. You've got to use certain words like close together. The data is closely clustered together, or the data is very far spread apart. But there's always that little element of uncertainty. Again, am I writing too much or am I writing too little? What I will do is I'll put the memo on the Google Classroom, and on the memo I'll write exactly what they wrote in the marking memo, because these are all past papers. So I'll show you exactly what they wrote in the marking memo, just so you can get an idea of what it is, the words that they like you to use. Yeah?
So why wouldn't it be perfectly accurate?
The only way it can be perfectly accurate is if all the points were located on a straight line. So in this case, it would look like that. So if it's perfectly on a straight line, I could go and I can say, yes, it's fairly accurate, but you can never make the statement it's perfectly accurate, because data, unfortunately, anything can happen. That's the problem with data. Literally anything can happen. And that's why it could be perfectly accurate over here, and like literally 2 steps on, it's no longer accurate. Okay, right. The one thing they always say about data is not, or predictions, especially if you're going to go into science and you're going to be doing predictions and modeling. One of the things they say is, and for instance, I know you guys really don't want to have a reference to the coronavirus, but anyway, the virologists modeling what's going to happen in our country with the coronavirus will all tell you all of their models are inaccurate. All of the models are inaccurate. The question is not about accuracy. The question is about how useful the model is. That's what data is about. Data is not about how accurate it is, it's about how useful it is. So if a model is useful, even if it's inaccurate, then they will use it. And then you go like, well, how can it be useful if it's inaccurate? At least it gives us a plan. You know what I'm saying? To be horribly inaccurate, but at least we have some type of plan. We have something we can do about it. That's what useful means. Doesn't have to be accurate, it just needs to be useful. Okay, right, next. An individual makes a prediction that if x has a value of 30, y will have a value of negative 33. His friend points out that he is extrapolating and that his result is not accurate. Explain what his friend is referring to. So you just need to explain what extrapolation is. You understand? So to explain the word extrapolation, it pretty much means that the value of 30 does not lie within the domain of the given data set. So 30 does not lie within the domain of the given data set. Therefore, you are making an inaccurate prediction. That's extrapolation. And you have to remember those words, extrapolate and interpolate. They want you to use those words. Okay, so here's the next question. Question 7. The diagram below shows the relationship between the time spent on an electronic device and the amount of time spent doing physical activity during the day. So you'll see the x-axis says time spent on an electronic device, and then the y-axis says time spent on physical activity during the day. Now, first question. And I want you to actually try this on your own, and then we'll talk about it. Circle the correlation coefficient that best describes the data represented in the diagram above. Circle the correlation coefficient that best represents the data. Then after you've done that, if you're uncomfortable, you can circle it with pencil, but I mean, you can circle it with pen and then just correct afterwards. If A and B were removed from the data set above, what would happen to, and then try correlation coefficient and gradient of the line of best fit. Try number 1, number 2, number 3, and then we'll talk about the answer. Okay, so I'm going to give you the accurate answers here, and we can talk about it. Right, so this was question 7. Right, so the first one, circle the correlation coefficient that best describes the data, minus 0.8. Now, why do you think it's minus 0.8? Because some of you might have wanted to go for minus 1. By the way, if you went for the positives, that's absolutely wrong, because very clearly that data has got a negative trend. Got a negative trend, got a negative slope. So if you went for the positive, that's 100% incorrect. That's wrong. Okay, so you have the 2 negative ones. Why would you go rather for the minus 0.8 than the minus 1? One, outliers. There are outliers. And you spot the outliers there up at the top, A and B. So because there are outliers, it's impossible for that to have a perfect correlation. If there were no outliers, you could maybe have gone and said, damn, that data is damn close. If we remove the outliers, I still don't think it will have a negative 1 correlation. It will be minus 9, something, but I still don't think it would be equal to minus 1. To be a perfect correlation, those points need to be very damn close to a straight line. Do you understand? So minus 0.8. But most of you guys select the minus 0.8. Okay, especially because of the outliers, that's a clear giveaway. Now the next one, if A and B were removed from the data set, let me just do this. That's better. If A and B were removed from the data set, what would happen to the correlation coefficient and the gradient of the line of best fit? So what do you think will happen to the correlation coefficient? Decrease. Absolutely. Decrease. Why? Because it's a negative correlation. So the moment I remove those 2 outliers, it means the data is negatively closer together. So because it's negative, it means it's going to go closer to negative 1, so it's going to decrease. Got it? Then the next one, what will happen to the gradient of the line of best fit? So if you look at it at the moment, then we would say it should have looked like this. if the outliers weren't there. Because of the outliers, it pulls it up like that. So by removing the outliers, it goes from this to this. So does that become more steep or less steep? More steep. Careful. So with negative, more steep means decreases. Yes, William. Yeah. You can say stronger, but be careful with the word stronger because I think they do want you to say stronger means closer to -1. So if you use the word stronger and brackets closer to -1, that's fine. But if you use the word decrease, that's also fine. I'll look at the memo just now and confirm. Okay, but that one obviously, the slope will get steeper, but because it's negative, it means the gradient will decrease. So what they said in the memo over here is they said it will get closer to -1 or decrease. So they wanted you to state for B1 that it will get closer to -1, so it will decrease. And they wanted you to state that it will decrease or it will get steeper. So if you use the word steeper, that's fine. But if you use the word decrease, that's also fine. Okay. So I don't like the word, the correlation coefficient will get stronger because they're probably going to ask you, what do you mean with stronger? Got it. Okay. Then the next one asked, circle the line below which best describes the person represented by A. A person who has just bought an iPad and plays computer games, a person who watches sport on television and likes to read books, a person who plays professional sport and studies via the internet. So A to B is strange because that person has high time on sport and they've got high time on the internet. Can you see that? So my X is very high and my Y is very high. So I need a description that tells me they do lots of time on both. So which one of those works? The last one, a person who plays professional sport and studies via the internet. That person will be high on both. Whereas if you look at the other ones, plays computer games means lots of time on devices, but not lots of time practicing. And a person who watches sport on television and likes to read books, that one is like, yeah, not the same thing. Okay, right, next one. Okay, so let's see if you guys can remember what we did on Friday. The table above shows the approximate number of visitors to South Africa from 2009 to 2013. Suppose the following variables are defined. X is the year, and Y is the number of tourists to South Africa in millions. Now, they want you to calculate the correlation coefficient. Okay, they say the correlation coefficient between X and Y is 0.98, correct to 2 decimal places. Comment on the correlation between X and Y. So what do you think is the correlation between X and Y if they say the correlation coefficient is given as 0.98? Remember 3 things we have to comment on. Very strong, positive, linear. That's it. Very strong, positive, linear. Okay. Then the next question says, use a calculator to determine the equation of the least squares regression line. Now, this question, when they asked it that year, was a really, really bad question to ask. And the reason it's a bad question to ask is the following. When you type in the Y values, do you type in 7, 8, 8,3, 9,2, 9,5, or do you type in 7 with 6 zeros, so 7 million, and then 8 with 6 zeros, so 8 million? How do you type it in? Without the zeros. Because they said, Y is the number of tourists in millions. You understand? So they define it already as in millions. So you're not going to put the millions in, because then you're talking about a million. You understand? Okay, so you guys use a calculator, please, and work out that least squares regression line for me. Let's see if you can remember how to do this. Okay, that's what I got. Y is equal to minus 1,238.42 plus 0.628. You guys are saying that. Again, I don't like the fact that they didn't specify rounded off to 2 decimal places, because generally what happens at the beginning of the paper, they go and they say rounded to 1 decimal place. You understand? And then you'll see that a lot of the time they will, for these ones, they'll ask you to round off to 2 decimals, 3 decimals, even 4 decimal places. But because they didn't specify, technically speaking, if you round off to 1 decimal, here they can't penalize you. They've actually got to accept rounded off to 1 decimal. Okay. Yes. Why is it worth 5 marks? Because of the amount of typing you have to do. They have to remember, just because it's so easy to do, they have to take into account how long will it take you to actually type all of that information into a calculator, double check the information, then bring up the A value, bring up the B value, so they do reward you for the time it takes you. Okay. Now the next question then says, use your answer in 2.1 to predict the number of tourists in 2018. So use that to predict the number of tourists in 2018. So that's simple, it's a substitution. So y is equal to minus 1238,42 plus 0.62 times 2018. So that seems to be 12.74, and you can just write the million there, because remember, the value is going to be in millions. Okay, the next question they ask, comment on the reliability of your answer in 2.2. I'm going to say nothing. You comment on the reliability, and then we'll check what you've got. Just use the word. Right. It is not reliable. Why is it not reliable? Extrapolation. The years that we've got up top goes from 2009 to 2013. So because it goes from 2009 to 2013, 2018 is about 5 years later. We do not know whether that trend continues or not. It's extrapolation. Extrapolation is always inaccurate. It doesn't matter that my correlation coefficient was 0.98. Correlation coefficient only comes into play if I interpolate. Then you can talk about the correlation coefficient. But the moment it's extrapolation, ignore the correlation coefficient, it's inaccurate. You don't know whether that data continued or not. Okay, right, next. Okay, next one then says, study the table below and answer the questions that follow. Now, we're not going to do this one right now. We're running out of time. What I do want to quickly talk about, I want to talk about the B part over here, where it says, the scatter plot below is a graphical representation of the relationship between a household's monthly electricity bill and their monthly water bill within the same suburb. Electricity bills between 100 Rand and 1,000 Rand were used in this study. Now, label the outline on the diagram above with the letter T. This is the easiest mark you will ever get in a matric paper. Unless you don't label it with the letter T, because you're not reading the instructions. See? Look. There you go. 1 mark for your matric exam. Okay, right. Then the next one. Comment on the relationship between a household's monthly electricity bill and monthly water bill. So comment on the relationship. Remember? Relationship, you can always comment 3 things. The relationship, the correlation, the association, it's pretty much the same thing. Okay, so positive is easy to comment. You can clearly see it's got a positive. Linear is easy to comment. You can clearly see it's linear. The strength is a little bit of an issue. Without that outlier, I would say it's a very strong correlation. You guys agree? With the outlier, it might actually take it down to being only a significant correlation. So you can get away with saying strong or significant because of the outlier. I wouldn't necessarily say very strong just because the outlier might just pull it under that 0.9, which means rather go with the word significant or strong. Okay, I wouldn't use the word very strong. Then the next question says, if the outlier was removed from the data above, how would this affect the correlation coefficient? What would happen? Increase closer to +1. Will increase or will go closer to +1? Then one last question, because we're kind of already over time. What subject do you guys have now? History. They're not going to be very happy with me for letting me go late. Okay, so let's rather stop right there. Yeah. Thank you, guys. I will put the memo for this worksheet on the Google Classroom. I'll do that. And if you have any issues, but we're kind of done with statistics today. I think you guys all agree it's really not that complicated. But please go through the worksheet. Make sure you do the worksheet. Mark your answers according to the memo that I'm going to put up. And then tomorrow, sorry to say, we're starting your linear geometry. So it's still your paper 2 book, but your linear geometry. Thanks, guys. Have a good day.
Thank you so much, ma'am.
Thank you, lovely people.